Hello and selamat sejahtera. My name is Bartimius Anak Tinggi, and today I will present about experiment 1, which is S1 tensile test. For the objective of this experiment, the objective is to obtain a general understanding of how different material and cross-section behave under an axial tensile loading. Second, to determine the stress-strain relationship and compare mechanical material property of various material and cross-section. And the last objective is to obtain the mechanical properties, the modulus elasticity, the yield stress, the ultimate stress, the fracture stress, and the ductility ratio. So for the introduction, the tensile test is the most commonly performed and is the simplest among of all the mechanical tests. In this experiment, a specimen is subject to a gradually increasing axial load until failure occurs. The typical testing procedure is to deform or stretch the material at a constant speed. A circular and rectangular cross-section will be used as test specimen, which is made of steel, copper and aluminium. The load deformation data is recorded during the experiment, so this data can be plotted once the procedure is complete. The student will learn how to properly conduct a tensile test and obtain the relevant material property from the result. Further, the student will discover how different materials as well as different cross-section behave under similar conditions. For the apparatus is universal testing machine, vernier caliper, steel ruler, 2 or 3 test specimen, maybe steel, aluminium and brass. Procedure. The first step, measure the dimension of each test specimen before and after test and fill in the table 1. Mark the gauge length on the test specimen, and number 2, switch on the machine. Number 3, mount the test specimen in the grips of the machine. Number 4, apply and record load and the corresponding deformation. And the last one, number 5, repeat step 1 to step 4 for various types of the test specimen. Okay, let's go to the result. As you can see at the table 1, dimension of the appropriate tested specimen. The material that we're going to use is steel, brass and aluminium. And you can see that all the value for the initial and final that I have filled up based on the table set 2 given by lecturer. So at the table 2 also you can see all the value that we got from the table set 2 also, and from this table we make the graph, and as you can see there is 3 table. First table is for steel, the second table is for brass, and the last table for table 2 is aluminium. So this is the graph that I have made. So this is a graph from steel, and this is the curve that we can got based on the table given. Next, this is the graph of brass, and this is the curve that we got from the stress strain graph of the brass. And the last one, this is the graph of aluminium. So this is the curve that we got from the stress strain graph from aluminium, and from all this graph we can fill up to find the elastic limit, yield point, load lower yield point, ultimate load, and breaking load. Okay, next. Okay, for the graph, for the last graph, for the last table, which is table 4. The table before that I show is the table 3, that show all the elasticity, yield point until the break load. So the last table is the properties for the tested specimen, and all this value can be find by check it into the graph and by the calculation. Okay, for the discussion, the first question is compare and discuss the result in table 4 to reference value and comment on the possible reason for the discrepancies of obtained for a tested specimen. So the answer is there is a lot different that we can see in the table 4. As we can see, the experimental value of the material is not same to each other. This is happen because steel, brass, and aluminium have different property to each other. So second question is compare and discuss the similarity and difference in mechanical material properties for the material tested. For the answer, both of these material, brass, aluminium, and also steel, has a good proportional limit stress, so that this material can be a good to use for a long time. They are both of alloy. For difference, brass have a good ductility compared to the other material, and also hygienic and non-corrosive compared to the steel, aluminium. So steel and aluminium is easily corrosion when exposed to the surface contact. Next, for the question 3, distinguish between yield point and yield stress on a strain stress curve, which give the more accurate indication of a material fitness for a particular tensile application. The yield point is the point on a stress strain curve that indicate the limit of elastic behavior and the beginning plastic behavior. Yield strength is the material properties defined as the stress at which a material begin deform plastically, where yield point is the point where non-linear elastic plus plastic deform begin yield point. Have more accurate indication of material fitness for a particular tensile application. So the yield point have more accurate indication for the material fitness for particular tensile application. And number 4, distinguish between the proportional limit and the elastic limit for each material, which is the more important indicator of a material mechanical behavior. So elastic limit is the point at which there is no permanent deformation in a structure, or the point at which the body regains its original shape, while proportional limit is the point at which stress is directly proportional to the strain. Proportional limit is more important indicator than elastic limit. This is because it's directly proportional to the strain. The last question for discussion: what are the advantages of stress strain diagram over a load deformation diagram for showing the result of a test? The answer is a stress strain graph give us many mechanical properties such as strength, toughness, elasticity, yield point, strain, energy, resilience, and elongation during load. So this is all discussion. So next, we go to the conclusion. For the conclusion, student able to obtain the objective of this experiment. Next, by doing this experiment, student will be able to conduct the experiment successfully with a correct step, and student will gain knowledge by do a strain stress graph to obtain the result for the properties of the material. Further, student able to choose the best material based on the final result of this experiment. Lastly, student will learn the importance of the cooperation as a team to share a task given, exchange opinions, and help each other to complete the experiment. Thank you. Safety precaution. Number 1, wear safety goggles. Number 2, wear lab coat. Number 3, wear suitable shoes. Number 4, follow the instruction given by our lecturer during the experiment. Number 5, do not eat or drink in the laboratory. Number 6, ask when in doubt.